Welcome to Ship It, a podcast about ops, infrastructure, and answering your questions. This episode was requested by Tyler Smith, who feels that he may not need Kubernetes just yet. Tyler has a few questions about Docker and Docker Swarm. So Andrea Luzzardi, former Docker Swarm lead, joins us today to answer them. We talk about the Docker Swarm beginnings, some of the challenges that it faced, and what Andrea's recommendation is for Tyler's journey with Docker Swarm. After dedicating 4 years of his professional career to Docker Swarm, Andrea is the best person that I know to talk about the subject. And guess what? The same thing happened now as it did at KubeCon 2015. Sam pointed to Andrea. It will all make sense in the first 5 minutes. This one is going to be fun. Huge thanks to Fastly for shipping her episodes super fast all around the world. Check them out at fastly.com.
Hey friends, this episode is brought to you by NetFoundry, the creator of OpenZD. OpenZD is the only open source way to embed zero trust networking into your app. This gives you unprecedented control and security. Give your app superpowers using an OpenZD SDK and a few lines of code, or use their tunnelers to spin up zero trust networking in minutes across any cloud or device. Never face the horrors of VPNs, DNS, inbound ports, or complex firewall rules. No networking engineering skills are needed. OpenZD is trusted by developers at Microsoft, Oracle, Ramco, and more. And if you don't want to host your own OpenZD, use the NetFoundry SaaS, which includes free forever tiers for up to 10 endpoints, so you can test things out for yourself. At netfoundry.io/changelog to learn more and get started. Again, netfoundry.io/changelog.
We are going to ship in 3, 2, 1.
A month or so ago, I was asking my Dagger team, who is a good person to talk Docker Swarm with? And Sam, he turned around and he pointed to the person that was sitting next to him and said, Andrea was the lead engineer on Docker Swarm, so maybe talk to him. Welcome, Andrea, to Ship It.
Thank you. Happy to be here.
So before this episode, I did like a bit of research, and I found so many good presentations, recorded ones, slides about Docker Swarm. So you did an excellent job promoting it, I have to say. This was 2015, 2016, a lot of good stuff.
Yeah, 15, 16, 17 also.
Yeah, it was a couple of years for sure. Why are we talking about Docker Swarm? That is a great question that I'm sure many of our listeners are thinking. Tyler Smith, one of our listeners, was asking about, let's have an episode about Docker Swarm, which prompted me to ask around and see who would be the best person to talk Docker Swarm with. So Tyler wrote, I use Docker Compose in development and production on a single machine. Tyler, I hope it's not the same machine. If you've learned anything, please tell me it's not the same machine. While I'd like to explore scaling my apps, I feel like I might not need Kubernetes yet. I would also like to keep leveraging my Docker knowledge. And he has the following questions. Before we cover the questions, I am so curious to find out from Andrea about the Docker Swarm story, how it started. Let's start there. How did the Docker Swarm start? The idea, the concept, the implementation. What did that look like?
Yeah, I'd be happy to talk about that. It's actually a very long story, so I have to go back a few years. So it all started with .cloud, which was, the company behind Docker at the time. Mm-hmm. So we have to go back to 2011 actually. And at the time, if you wanted to deploy an application, you had two choices. So either you manage your own machines, like provision a cluster, either on bare metal or with EC2, and kind of figure out a way to provision your services manually or using Salt or Ansible. Or if you're lucky enough to use Ruby on Rails and Postgres, then your answer was Heroku. But there was nothing in between. If you happened to be using Django and MySQL, then you were out of luck. Yeah, you had to provision your own cluster. And so that was the premise behind .cloud, was that it was like Heroku, but it was any language with any database. And turns out that it's pretty hard to do because, now you have to handle a bunch of different languages on every machine with different, versions per language. And that's not something simple to do. Also at the time, it was impossible on EC2 to run VMs because you were already in a VM. So that's where containers came in. And we discovered, C groups and namespaces, and we kind of like started to create like our own container runtime internally. And that's basically the ancestor of Docker. But there was no tooling around that. So we had to build our own like container builder, which eventually became Docker build. We had to build our own registry. We had to build our own load balancer because load balancers were meant for machine to machine, but not machine to container. So it's actually Sam Alba that created like something called Hipachi, like the Apache for hipsters. That was like an HTTP load balancer for containers. And finally, we had to put those containers into machines. And so we created like a container orchestrator internally. And so we had this entire stack with basically what, eventually became Docker, the registry, Docker Hub, Docker Build, and Docker Swarm. So we had all this platform back in 2011, and a few years go by, and then Heroku now has build packs to, build like any language. And so they were getting like a lot of attention from the community. And we thought like that was pretty cool. Like, why don't we open source the core of what we have, starting by the container runtime? And so that's where Docker came to be in 2013. And so that's kind of the long history behind that. And so in 2013, we open sourced Docker. And about a year after, in 2014, we reached, 1.0 that was announced at the first DockerCon. And, people started to, have questions like, how do I do this or that? And for instance, some of the questions were like, okay, now I have a container, but I need to, run my entire application. And people were starting to do some hacks around that, like, shoving an entire init system, like systemd inside the container to run multiple processes. And we were trying to push like a new approach of just running a single service per container. And so basically having multiple containers like microservices. And then the question arose like, how do I, I can Docker run one container, but how do I do that with multiple containers? And so that year we released Docker Compose to, be able to describe the app. And then the following question was like, okay, now I've composed, but like I'm running this on my laptop. How do I run this on a different machine? And I don't think at the time there was any Terraform, or at least it was not popular enough. So we released Docker Machine. Like, so now you have Compose, you have Machine, and you can deploy your containers to like one machine. But now, if you start 3 machines, like how do you manage that? And that's where Docker Swarm came to be. And we were not talking about orchestration back then. It was much simpler than that. It was like, we have this very popular Docker API that works with one machine. How do we make this API multiple machine? And so Docker Swarm was this very simple API multiplexer that was completely stateless. You could join like a couple machines together. It would just, boot up, scan the state, and give you the same, Docker PS API and see the entire cluster with the machines. And Docker run would just pick one machine, Docker restart, and all of that basically just made it multi-machine. And so that's pretty much the how Docker Swarm came to be.
Okay. So it was this multiplexer. Okay, so hang on. First of all, Sam was a hipster? I still can't get over that.
Well,
no way. I can't imagine, Sam.
Yeah, it was a load balancer for hipsters.
Right. Okay. I see. Okay. I have to ask you where you got the inspiration from. Maybe we very quickly say, hey, Sam, can you join this and like answer this question? But no. I'm going to ask it offline. And maybe if someone's curious, we can share the answer via Twitter or something similar.
We're not very good at naming stuff.
Yeah. I thought Solomon was the hipster. No. He was obviously very, very popular, and he was very excited about Docker. And that's actually how I got into Docker, like that excitement, and that like the story in that you can take it from a really simple, like from your local machine, and you can go into production and you have something very similar in production. It's the same familiar API. I really like that. But you're right, there was like, so how do I scale this from one machine to multiple machines? And when I had to do that, say, okay, well, it kind of makes sense. It's nice that I can join them, but what happens afterwards? How do I do upgrades? How do I handle my stateful stuff like my database, my PostgreSQL? What happens with the volume? Like, will it move around? What about the whole plugins where, for example, I want to stream those logs to a log aggregator and metrics, and then you have to have all the questions like start coming out of that. So I'm wondering, Andrea, how did you go from this Docker Swarm, which was just a multiplexer, to a system which needs to handle distributed config, which needs to handle networking across multiple hosts and rebalancing things and volumes moving, basically all the things that Kubernetes does? How did you go from that simple multiplexer to something more? What did that journey look like?
So we started with the multiplexer, which released in 2015. And then, the community came back with questions. Well, basically everything you said, like, okay, now I have two containers running, but how do they talk to each other? And, how do I attach storage? And Swarm at the time, like we built it with the same principle as Docker. Like it must be, good DX, simple to install, simple to use. And Swarm basically followed that by being, stateless and using the same Docker API, but realized that the Docker API, which was designed for single machine, didn't cut it anymore. Like we needed something. And that's where Swarm mode, so the internal component Swarm kit came to play. The idea was twofold. One, we're going to have a dedicated API for multiple machines. So that's the Docker Service API that contain, more hooks for multi-machines, like what's the replication strategy, how many instances you want, do you want to pin this container to a specific machine, and so on and so forth. And then also having state, finally, like you cannot do, complex cluster management without state. But what made it hard is that we didn't want to have to, set up, an etcd cluster, like a 3-machine etcd cluster to manage like one production machine. So that was really the tricky part. And so that's where most of the engineering went, was like we started to basically have a Raft implementation. So we took like etcd's core Raft implementation and bundled that into SwarmKit so that nodes could just, talk to each other and reach consensus. And then we created this Docker Service API on top. And in addition to that, we pushed also other parts of Docker, to become modular. So we had Docker networking modules, Docker volume, modules, and kind of like started to have multi-machine built into that. So that happened, I think Swarm was stable in 2015, and probably like a few months later, like end of 2015, we started to work like on this new mode, which we announced, I think it was DockerCon in 2016, so around June. So it took us 7 or 8 months to come to that.
Yeah.
And so, that's how we went from a simple multiplexer to a full-fledged orchestrator. At the same time, there was Kubernetes that was available, but it was kind of, hard to set up and manage and use. There's the very famous documentation by Kelsey, like Kubernetes the hard way. But at the time, it was actually, Kubernetes the only way because there was no managed service. There was nothing. So you had to jump to many hoops to get a Kubernetes cluster up and running, and wanted to provide, something simpler, not the only way of doing it, but from what we're hearing from the community, we just wanted something, for small size clusters. We didn't want to manage 10,000 machines. Most applications at the time were like pretty simple because Docker was not really great at multi-tenancy. Like on a single machine, like you could not have multiple customers fighting for the same CPU because isolation was not great. So people were managing, many small cluster rather than like a, 100 machines cluster. And so at that time, the strategy made sense.
So you mentioned Kelsey Hightower, and I'm very glad that you did. Not only we had him recently, and he mentioned Kubernetes the hard way, how famous it became, and how many people drew inspiration from it. But he's also the same person that introduced you and Sam at KubeCon North America 2015 when you talked about Docker Swarm and Kubernetes. That was the title of the talk, Docker Swarm and Kubernetes. And what Kelsey said is it's the first talk where he knows that the boss made someone else present, not someone else. The boss made someone present at the conference because Sam was presenting with you, and at the time he was your boss. Now, I'm wondering if the same thing happened now, because I asked who knows Docker Swarm, and Sam went, Andrea does. So he basically volunteered you for ship it. Oh, damn it, Sam, you got it again. So one thing that you mentioned at that conference in the talk was how Docker Swarm 1.0, how you benchmarked it to 1,000 nodes and how you could run 30,000 containers. What was that like to benchmark that, to realize the scale that it could reach? Because I'm pretty sure at the time, Kubernetes was not able to run 1,000 nodes in 2015.
Yeah, for sure. That was actually like a very interesting talk. As I said, like the goal again was to make, running on multiple machines easy. And so we had, Swarm had a built-in orchestrator, but the goal was not to push orchestrator like everywhere. Like we actually had support for Docker Swarm backed by Mesos. And the reason we were at the first like KubeCon was to announce that Docker Swarm supported like running containers on Kubernetes. Like we just wanted to have, the Docker API simple enough, but if you wanted to run like a Kubernetes cluster or a Mesos cluster, so be it. Like you could, point Swarm to your Kubernetes cluster and just, do a Docker run and it worked. So the built-in orchestrator that was just for, if you didn't have, neither Kubernetes nor Mesos, well, we had a simple one baked in. That was the goal. Turns out the built-in one was so simple because again, stateless, just a multiplexer that when we tried to, we're wondering like, what's the scale? People were saying, oh, it's so simple. Like, will we handle like 10 machines, 20 machines? So we just fired up a 1,000 nodes cluster and we're running commands against it just to, see how it would go. And it didn't break at all. So that was not the intended purpose. I think internal automation, we're regularly pushing it, I think, to 20 machines. That was like the target. We didn't think like at the time anyone would, run it above 20 because again, like multi-tenancy was not great. So many clusters for one company rather than a gigantic cluster. Also, it was, in 2015-ish. So people are just migrating to containers. Like they didn't have their entire infrastructure on containers. Maybe they had most of the machines were managed manually. And then maybe they started to have like one cluster on the side just for containers. And it was like more or less per team or per service. I guess the 1,000 machines happened. It was a happy incident, but not by design.
Yeah, that makes sense. I mean, even now, to be honest, what people recommend is run small Kubernetes clusters. Don't run big ones. It's an anti-pattern. You'll start hitting various issues around DNS, around networking, around scheduling, if you run too large containers. So this is a known thing even today, and it's not recommended.
Yeah.
Not like weird things happen in large clusters. Was what people are saying. The ones that tried and failed.
And beside the technical challenges, there's also like simple challenges like cost management. Like because most of the billing is per machine, if you start to mix everything together, you don't even know like, hey, how much like this production service is costing us. Now I think there's tooling that can, take a deep dive inside Kubernetes to figure out like cost per service, but at the time, like you were built by machine. So if your entire company was running a single cluster, you would have like one invoice and then good luck figuring out like why the cost was increasing.
Yeah, that's a good one.
This episode is brought to you by our friends at Sentry. Build better software faster, diagnose, fix, and optimize the performance of your code. Over 1 million developers and 68,000 organizations already use Sentry. That number includes us. Here's the absolute easiest way to try Sentry right now. You don't have to do anything. Just go to try.sentry-demo.com. That is an open sandbox with data that refreshes every time you refresh or every 10 minutes, something like that. But long story short, that's the easiest way to try Sentry right now. No installation, no whatsoever. That dashboard is the exact dashboard we see every time we log into Sentry. And of course, our listeners get a deal. They get the team plan for free for 3 months. All you gotta do is go to sentry.io and use the code changelog when you sign up. Again, sentry.io and use the code changelog.
So I'm going to switch to one of Tyler's questions. And one of the first questions that he asks is, what are the differences between Docker Swarm and Docker Swarm mode?
Okay, I think we briefly touched on that before, but the transition from the two was like from going from a stateless multiplexer to an actually full-fledged orchestrator. So I think maybe it's a naming fail. Like it's so similar, like there's only the extra word like mode, but they have nothing to do. Like one was a multiplexer that would run as a separate container, whereas swarm mode was this, stateful thing built into Docker that, had a new API, like the services API. And even though it was baked in, it was off by default. Like it wouldn't there was another goal. Like if you don't use Swarm, you just install Swarm mode, sorry. If you just install Docker, the memory footprint is the same. But then you would just type, Docker Swarm init, and then it would just boot up the internal process. So yeah, same name, entirely different project.
Okay. So Docker Swarm mode is when you run Docker Swarm init.
Yeah, that turns on the Swarm mode, which boots up the internal Swarm kit. So we had, this naming scheme with build kit, Swarm kit, VPN kit, and all the kits. And those are basically things that run inside Docker, like build kit that powers Docker build, and then Swarm kit that powers Docker Swarm init.
So how do you go from Docker Swarm mode, Docker engine or Docker daemon, which runs in Swarm mode, how do you go from that to Docker Swarm? Is it just a matter of joining multiple Docker Swarm hosts? Is that it?
Yeah, that's exactly it. You pick one machine, you do Docker Swarm init, and then on any other machine, you do Docker Swarm join and then the address of that machine. And they start to form a cluster and reach a consensus, join the Raft consensus and share network information and start replicating stuff. So that was the goal. It's a one command and you have a cluster.
And that's what you want to be very careful when it comes to consensus, when it comes to the number of nodes that you have. So always have an uneven number of nodes. I'm wondering, how does Docker Swarm, pairs, two, for example, two nodes, how they reach consensus if they couldn't talk? Who would win? Which side would win? Split brain scenario. That's what I'm thinking.
Yeah. We put a lot of engineering to make it easy. Maybe too easy, because then, engineers are okay, this is easy, but how does it work? Because I want to know. And the way it works behind is that it tries to pick same default. So when you init, you run in a single leader mechanism, you have a single Raft node. When you join another node, that one is also, it's just it's not part of Raft. It's just a node set to run containers. When the third joins, then they form a Raft cluster.
Interesting. Okay.
And when the fourth and so on, there's no more than 3 Raft basically members, because that's too much. You could actually change in the config between 3, 5, or 7. Above 7, it doesn't make sense. It's too slow and there's too many edge cases. But internally, you could configure a number, by default it was 3. The first 3 machines to join, part of Raft. The other ones could just run containers, and that's it.
Interesting. Okay. And would the Raft members move around? So let's imagine you have 5 containers, but you have only 3 members, part of the Raft cluster. Let's imagine that one node, the one which runs one member, dies. Would the Raft membership move around to one of the running nodes, which is just running containers? Is that how it would work?
Yeah, actually, there were a couple commands to manage that. There was Docker Swarm promote and Docker Swarm demote. So Swarm would pick 3 machines to decide what to do, with Raft, the first 3 to join. But then we were not shifting consensus around, because that's a risky operation. To shift consensus around, you either have to currently have consensus, you cannot, if there's a net split, there's one machine on the side and 2 on the other. You don't know, did the other 2 die or did a net split? And so we didn't want to change Raft topology dynamically, because that's very dangerous. But we provided tools for the operator basically to change membership status between the nodes with promote and demote. So you would do a Docker node list. You would see all the nodes. You would see which ones are part of Raft and which one is currently the leader node. And then you could, promote some other nodes or demote others, and it would just figure it out dynamically.
This brings back so many memories from years of discussion on the RabbitMQ team about quorum queues and how should Raft be implemented and what semantics it should have and which parts of Raft are safe. And when you throw in the real world operational aspect, nodes getting overloaded, network splits, all sorts, like nodes getting upgraded. What do you do then? There's so many hairy situations. And what you just mentioned just brought all of that back. You don't know what the right solution is. And end users would tell us, but why don't you fix this? Well, we can't. I say, no, of course, like you're lazy. No. I know, like you're not doing your job like properly enough. No, actually, it's really hard, and then by the time you like start talking, no, it's just a bunch of excuses. So yeah, there was some very tricky conversations along that history. I think we can have time for one more question from Tyler. Mm-hmm. And before we go back to a slightly different topic. When might it make sense to use Docker with swarm mode in production? That's one of the other things that Tyler was wondering. What would you say, Andrea?
Good question. I think it's very different today from what it was back then. I think my answer today would be like, if we're asking me like, where would it make sense to use MySQL versus Postgres? I would just say, just use RDS, just use a managed service. Mm-hmm. I think Swarm today is still one of the easiest way to manage your own cluster. If you want orchestration in containers, like it's simple enough to set up and operate. Although I think, managing your own cluster, there's use cases behind that. But by default, I would just encourage everyone to use like a managed service. Could be like a managed Kubernetes cluster, or even like a managed proprietary service like Amazon, like AWS ECS. Mm-hmm. Or anything basically where someone else, gets paged when the management plane breaks and
when the Raft consensus algorithm breaks or it needs help. That's basically what you're saying. It's hard enough, to have someone to worry about that, which is what happens by default with Kubernetes, right? You don't even know there is such a thing because, the management plane just have an API to it and that's it. You're not concerned with the operation of the management plane. So that's what you're saying. Okay.
Yeah, unless it's part of your core business, I don't think you should be fiddling with, Raft consensus at 2 a.m.,
Okay. So do you know if a managed Docker Swarm service exists today?
So there were a few incarnations of that. I think at some point, AWS had a Swarm compatible service. So I think they supported like with a specialized CLI, they could parse like a compose file, and Docker Swarm supported to run like a compose file as a manifest file. So AWS, there was this special CLI which would take a Swarm compatible file and convert it to, I think it was ECS or maybe something else. So you could, in a sense, like use a managed Swarm, even though the implementation was not Swarm, but API compatible.
I see.
I don't know if that's still around, but it used to be around. We used to discuss with the AWS team, things that would not work, on that particular service would, try and make the API compatible as much as we could to make it like semi-managed, I guess.
Yeah, that makes sense.
This episode is brought to you by our friends at Fire Hydrant. Fire Hydrant is the reliability platform for every developer. Incidents impact everyone, not just SREs. Fire Hydrant gives teams the tools to maintain service catalogs, respond to incidents, communicate through status pages, and learn with retrospectives. What would normally be manual, error-prone tasks across the entire spectrum of responding to an incident, this can all be automated in every way with Fire Hydrant. Fire Hydrant gives you incident tooling to manage incidents of any type with any severity with consistency. You can declare and mitigate incidents all inside Slack. Service catalogs allow service owners to improve operational maturity and document all your deploys in your service catalog. Incident analytics let extract meaningful insights about your reliability over any facet of your incident or the people who respond to them. And at the heart of it all, incident runbooks, they let you create custom automation rules to convert manual tasks into automated, reliable, repeatable sequences that run when you want. Create Slack channels, Jira tickets, Zoom bridges instantly after declaring an incident. Now your processes can be consistent and automatic. Try Fire Hydrant free for 14 days. Get access to every feature, no credit card required. Get started at firehydrant.io. Again, firehydrant.io. and by our friends at Retool. Retool is the low-code platform for developers to build internal tools. Some of the best teams out there trust Retool: Brex, Coinbase, Plaid, DoorDash, Legal Genius, Amazon, Allbirds, Peloton, and so many more. The developers at these teams trust Retool as the platform to build their internal tools, and that means you can too. It's free to try, so head to retool.com/changelog. Again, retool.com/changelog.
So I remember in 2018 when we were thinking of migrating, or I was thinking about migrating from a Docker that we used to install with Ansible on Ubuntu and then converted into Docker Swarm. And I think we only had one at the time. We converted to Docker Swarm to be able to use the API and whatnot. Or maybe I'm misremembering this part. Maybe we weren't using Docker Swarm. But anyways, we were basically managing our own Docker instance in production, and that was not fun. And in 2018, I thought, you know what? How about we pick an operating system that has Docker pre-installed and it manages all of this and upgrades and Docker upgrades and all that. So that's when we picked CoreOS. It came with Docker. It had a lot of the mounts were read-only. That was great. The upgrades were very nice in that you could like self-upgrade itself, and we liked that. There are a couple of quirks there, but I was really excited about going to Docker Swarm. And that was 2018? It must have been 2018 because at the end of 2018, like for 2019, we went from Docker Swarm to Kubernetes. And that's something that Tyler is asking, should he just go to Kubernetes or should he use Swarm? Having used both, I liked like a lot of things that you mentioned. First of all, it's a managed service. So Kubernetes these days, you just get it as a managed service and you don't have to worry about like the little intricacies around, the control plane, the worker nodes, all that stuff. So having a managed control plane is such an important thing. That was the first thing. The second thing was around the ecosystem. So the reason why we went to Kubernetes from Docker Swarm end of 2018, beginning of 2019, was because we could all of a sudden install these things on Kubernetes and not have to worry about packages. So the value line moved up. We could get a Prometheus, for example, and we didn't have to worry how it comes from, how it gets wired, all those things. It was much, much easier. There was something like external DNS, which was very nice. So part of that, we stopped using Terraform. We went to Kubernetes. Of course, Kelsey told me that's a bad idea. Like, don't do that. Like you want a control cluster and then you want your workload cluster rather than mixing the two concerns, which is what we did and we still do today. So there's some food for thought for me and things to improve for sure. But the migration was fairly simple, I have to say, and it felt like it's a step in the right direction. So I'm wondering, where do you sit when it comes to this, Andrea? Would you use Docker Swarm for production if it was managed? Would that be enough for you to pick Docker Swarm? Is it just like that managed part? Or would you go to Kubernetes? What would you pick and why?
Yeah, I think it really depends on the use case. I've been using, for instance, like myself in the past, I've been using ECS to kind of get a managed service with a little bit easier to use as a user, but really depends on what I'm trying to do and if I value, porting from one cloud provider to another, for instance. I think I would probably consider Swarm if I was running like an on-prem cluster or, a cluster, a provision manually with machines, but I wouldn't do that. Like, I think unless, I have some weird requirements about the machines or like it needs to be in a cage, a control or something like that. But I think by default, for regular, web application, I would just use a managed service, whether it's Kubernetes, ECS or something else.
Okay.
I think one of the main reasons is about ecosystem. And, if I run into problems, I want to be able to Google the problems and, hit, see some people that run into the same problems as me and so on and so forth. So, yeah.
So this makes me wonder, why do you think Kubernetes became so popular over the years? Because at one point, Docker Swarm was so much more advanced than Kubernetes, right? And at one point, as you mentioned, you could run containers in Kubernetes via Docker Swarm. So in a way, the integration was the other way around. Kubernetes was running Docker engine for a long time, and then the Docker shim was removed, and the whole runtime change, the container runtime change. That was like a huge deal. But at some point, Docker Swarm, I'm sure it was a great choice. And people say Kubernetes, okay, it's a new thing, not so unproven. And because you had Docker, right? And Docker was a great tool. And even to this day, a lot of people depend on it, and it's just so easy. It's like the easiest thing. So I'm wondering at what point did Kubernetes, I don't want to say was starting to get maybe more popular, and why? I mean, that always fascinated me. I think we had the Kubernetes documentary, so I have a lot of the Kubernetes story, but I'm missing the Docker and the Docker Swarm story.
Yeah, I think the main reason behind that is that Swarm was about, again, it started with a simple promise of you have one Docker machine and now you have multiple machines, and we're going to help you with that. Whereas Kubernetes is much more than running containers. It's this, this set of API construct where you can do a bunch of stuff on top. Running containers is one thing you can do. And at the beginning was the main thing you could do, but it was very much extensible. It was easier for the ecosystem to plug into that, for load balancers to plug into that, to have third parties plug into that. And so I think that really contributed for the ecosystem to kind of standardize on that. It was hard at the time. If you wanted to, swap something out of Swarm, you had to make a PR against Swarm and do that. So it was hard for vendors basically to come in, because also we didn't want to approve, every single vendor PR that came in. Yeah. We call those drive-by PRs, where a vendor would drop their PR and it would be buggy 6 months later, but it would never, contribute resources to fix it. And so we're kind of, solving one problem of running containers, whereas Kubernetes started to be this orchestration API, not just orchestration. It was a cloud API where a bunch of vendors could just standardize on that with a YAML file, come in, drop their controllers. And so I think that's the reason why Kubernetes became so popular. The thing to remember also at the time is that it was not, Swarm versus Kubernetes. There were many tools around, you mentioned CoreOS, and for instance, CoreOS had Fleet to, manage, a bunch of containers. There was Nomad by HashiCorp, which is still around and works great as far as I know. There was Swarm, of course. There was Kubernetes. There was Mesos. That was used by enterprises. A lot of big companies were using that. And so
Apple, I remember.
Yeah, I think they were one of the biggest users of Twitter also, were using Mesos. And so it was a time where there were a bunch of tools for different needs. Mesos for enterprises, and Fleet, if you were into the CoreOS kind of ecosystem, it maybe made sense. Nomad, for HashiCorp made sense. And then Swarm, it's this built-in thing, simple to use. And then Kubernetes takes it in a different approach where it's an API, but at the end of the day, the ecosystem standardized so much that it kind of, overshadowed all the other tools. But back in the day, there were 5 or 6 different tools, and with many users in each, and to each their own, depending on the use case.
Yeah, that's actually a good point. I forget about the other tools. You're right, they were there. I remember Mesos. I remember trying it and thinking, wow, this thing is really complex. At the time, I was into Cloud Foundry, and I was part of the Cloud Foundry ecosystem. And I like that idea around how simple it is compared to it was almost as simple as Heroku. I really like that. There was Bosch, the whole management of Cloud Foundry and all the services that you had, the stateful services. So there were some good things in that ecosystem, which, I worked on for a bunch of years. And at one point that was the simplest thing. So you're right, there was so many more things, but somehow Kubernetes just, eclipsed everything else. That's what happened. And I'm wondering what comes after Kubernetes. That's something which is on my mind a lot. And I see Docker, and I see Kubernetes, and then I see something else. And I'd like to think on my best days that I'm working on that something else, but we'll see. We'll see when it launches, and we'll see, how the users adopt it and what happens afterwards. So, but that is a topic for a different day for sure. So when it comes to Docker Swarm, what are the good memories that you have from the time that you spent working on it? Maybe something that's memorable even to this day. something that you're proud of, something that, it always makes you smile? Do you have a couple of those things?
I have a ton of fun memories with Swarm. I spent, I think, overall, probably over 3 years working on that. At first it was with my coworker Victor Vieux. It was just the two of us at the very beginning, and yeah, I have a bunch of memories like going to all these conferences and meetups and getting like a ton of questions and excitement. Like people were excited because we were answering like a problem they had. But I guess my fondest memory must be like 2016 when we introduced Docker Swarm. And it was hard. It was especially hard because we were trying to make something simple. And to make it simple, we had to pull in every team working at Docker to make it happen. So, we had a few, core goals for Swarm. One was to be simple. So with a bunch of help with draft and consensus and stuff like that. The other one was to be secure by default. So the security team helped us a lot with, mutual TLS and things like that. We needed a bunch of help from networking to do multi-host networking. Also, suddenly everything that used to work fine in single machine was completely broken. Like the volumes API, Docker volume create, that works with one machine, but now we need plugins. Or even the engine itself, since it could optionally run an extra process, like we had to change it. So we ended up having like the entire company, basically all the teams working in a way or another inside the project. And that was really, really fun to see.
Yeah, nice. Oh, I can imagine. I mean, Docker, it was like such a craze when it first came, like the first couple of years. And then there was like all these things, like the additive nature of like the various things that you mentioned. And then Swarm came along. I remember that there was a point where I couldn't keep track of all the things that were happening. There was like so much coming from the Docker ecosystem. That was quite the sight to behold. Like even like on the receiving end was overwhelming just to see how many things were happening and how quickly they were happening. Some very big challenges for sure. Is something that you would have done differently, knowing what you know today?
Honestly, I don't think so. I think we did what we did with the information we had at the time. And again, I think like the ecosystem was entirely different back then. Like containers were a shiny new thing. People didn't know what to do with them. And people were still running like VMs with like shell scripts at boot time to kind of configure dependencies or cloning
that
like
happens
AMIs.
Today.
Yeah.
Hasn't changed much.
Yeah. But right now it's kind of niche to do that. Whereas before that was standard, like by default, like you would clone AMIs, manage AMIs. There were actually a few cool tools from HashiCorp like Packer to actually create like your AMIs more programmatically. But I think given the information we had, like that's the best we could do. So I'll probably do exactly the same thing.
So as we prepare to wrap up, what would you say is the most important thing for Tyler as he's considering whether to go Docker Swarm or whether he should bite the bullet and go for Kubernetes? What would you tell him?
I would say to Tyler to look at your requirements and what you're trying to achieve. And I would suggest to, unless it's part, you have some special requirements, I would strongly suggest to go towards a managed service. Doesn't need to be Kubernetes, can be like ECS or Cloud Run or Lambda, or depends on, what kind of payloads you want to run. But I would advise against, running machines and getting paid for machines. I think in 2022 now, like there's no need to be paged in the middle of the night because a machine went down. So I would, suggest yes to, maybe if you find Kubernetes to be a little bit too hard to learn, I would ask like, what are you trying, what kind of payload are you trying to run? And if it's a simple web service, maybe you could consider like a Google Cloud Run or Fargate, or there's many other services than Kubernetes. But the suggestion is the same: is to look for something managed and not to worry about machines.
That's a very good point. And even if you have to use the platform as a service these days, whether it's Heroku, whether it's Fly.io, whether it's something else, it doesn't really matter. Maybe that's enough. Maybe that's all you need. If all you're trying to do is run some images and you have a database and that's about it. Okay. Andrea, it's been an absolute pleasure talking to you. Thank you very much for joining me. Tyler, I hope this was helpful for you. And if you have any follow-up questions, drop them in the comments. There will be a lot of links in the show notes. Enjoy some talks from 2015, 2016, some slides from Andrea. Some of them are really, really good, by the way. Yeah, see you around, Tyler. And thank you again very much, Andrea, for joining me today.
Thank you so much. It's been a pleasure.
Thank you for tuning into another episode of Ship It. Check out our other podcasts for developers at changelog.com/master. You can connect with like-minded developers from all over the world via changelog.com/community. Thank you, Fastly, for the worldwide low-latency changelog.com. Our listeners love those blazing fast MP3s. Your beats are awesome, Breakmaster Cylinder. That's it for this week. See you all next week. My last thing for today is to mention that Andrea is the first guest in the history of Ship It to have 2 back-to-back episodes. Next week in episode 48, we'll talk with Andrea, Eric, Sam, and Solomon about launching Dagger and what happens next. It's going to be great.